5-44, and it's not exactly like I'm going to do 543. It's not exactly like 544, but hopefully we can explain a little bit more about why we choose permutations or combinations. So let's take a look at the 43. It says an overnight express company must include 5 cities on its route. How many different routes are possible, assuming it does not matter in which order the cities are included? So, let's go back and look at permutation, right? Okay, and especially in the blue box, on the bottom of page 162, it talks about ABC is different than CBA. Okay, and in this case, that's what we would be talking about, right, as a permutation, because ABCDE is different than EDCBA, right? One route's forward, one route's backwards, but they're technically different routes. Okay, and so in this case I have a permutation, and my answer, and the book, I think, gives you in the back, it just says 5 factorial. I don't think that does a really nice job of explaining it. Really, it's a permutation of, and let's take a look at it, permutation of a number of 5, right? We have 5 stops, okay, and 5 potential. Okay, and so if you do the math, it does work out to 5 factorial. It's the same, but plugging that into the permutation formula, then it allows us to come up with that same answer, right? Because the bottom becomes a 1 when you have the permutation formula. So again, look at your problem, and for your guys is number 44, and which says, let me read it. Representative of the EPA wants to select samples from 10 landfills. The director has 15 landfills from which she can collect samples. So if those landfills are, give them names or give them numbers, right? 1 through 15. So our 1 through 10, if I'm just selecting samples, is 1 through 10 different than 10 through 1? Would it matter? Okay, so use that logic, I guess, when you're trying to select which formula to use, and then, and then the actual answer becomes easy.